Hi everyone, Mr. East here. I'm going to take you through today's lesson, and we're going to start off today's lesson by thinking about what Mrs. Sawyer set you at the end of the previous lesson. Your task was to find 16 objects, or to imagine those 16 objects or draw them, and think about how they can be grouped in different ways so that we can find fractions of those 16 objects. Now, this is a sentence that you'll say time and time again through this lesson, and you also used it in the previous lesson. It says, the whole has been divided into equal parts. One of these parts is one of the whole. So if you didn't have a chance to do this now. Find 16 objects at home, or draw some different representations of these 16 objects divided into different numbers of equal groups, and then think about what fraction one of these parts is of the whole. So if you haven't done that, do that now, but if you have, let's go through that together. So the first way that we could divide these 16 counters is like this. Here I can see how many groups I've got. I've got one group on top and one group below, so there are two groups, two parts. We need to check that they are equal in size. This group has got 8 objects in, this part has got 8 objects in, so we can say they are equal. Now let's say our sentence stem together. The whole has been divided into 2, that's what we just said, 2 equal parts. One of these parts is 1/2 of the whole. We write that like this. 1 is our numerator. Our denominator is 2. It's 2 because, like we said, there are 2 equal parts. You might have arranged them in this way. I can see that there are 1, 2, 3, 4 equal parts. The whole has been divided into 4 equal parts. One of these parts is 1/4 of the whole. Is there another way we can say 1/4? This is how it's written. 1 is our numerator because we've selected one of these parts. 4 is our denominator because, like we said, there are 4 equal parts. Another way to say this fraction is 1/4. Let's say both those sentences again with this information. The whole has been divided into 4 equal parts. Are you saying this with me? I hope so. One of these parts is 1/4 of the whole. Are there any more ways to divide these 16 counters? I think so. Here is another way these 16 counters could be divided. There are 4 groups on top, another 4 groups below. 4 plus 4 is 8, so there must be 8 groups. Just check them quickly. Yep, they are all equal in size. So let's say those sentences together. The whole has been divided into 8 equal parts. One of these parts is 1/8 of the whole. I write 1/8 as 1 as my numerator, 8 as my denominator. Any more ways? I think there's one more. Here I've taken my 16 counters. I can see there is one counter in each group. That must mean there's 16 groups. 4 times 4 is 16, so yep, there's 16 parts in total. Let's say our sentence together. The whole has been divided into 16 equal parts. One of these parts is 1/16 of the whole. That's written as 1 as our numerator and 16 as our denominator. In today's lesson, we're going to continue to think about unit fractions. And a unit fraction is when our numerator is 1, because we're thinking about one group or one part, and our denominator will change based on how many parts there are. So in this first context, I can see there are some children. Maybe they're your friends, maybe they're children from your class. Now, the slight difference from before is not both of the parts are circled. This first part is circled, but the second part isn't circled. But I can still see they're equal in size because I can see there is the same number of children in each part. And I can still see the number of parts because of how they're laid out on my screen. So I'm going to say these sentences for this first example. The whole has been divided into 2 equal parts. One of these parts is 1/2 of the whole. Now, just like in the example before, we can write 1/2 as 1 as our numerator and 2 as our denominator because one of those parts has been circled and there are 2 of those equal parts. Now I'm going to change the picture. I've changed the number of parts, haven't I? But there are still an equal number of children in each part. So we can still say what fraction of the whole has been circled. So do this one with me this time. You ready? The whole has been divided into 3 equal parts. One of these parts is 1/3 of the whole. Now we write 1/3 like this. 1 is our numerator and 3 is our denominator. Now, why is 3 our denominator? Is it because there are 3 children in this group? There's 3 children in this group. There's 3 children in that group. Is that why it's 1/3? No, if we go back to our sentence scaffold, it's 1/3 because the whole has been divided into 3 equal parts. It's the number of parts that's important, not the number of children in each part. It just so happens that in this example, there's 3 children in each part as well as there being 3 parts. Hopefully that wasn't confusing. Let's look at another example and make sure we're all happy with the fraction that has been selected. I've changed my picture again. I've changed my image. If you spotted, there's another one of these parts. They're still all equal, but there's an extra one. This time there are 4 parts. Let's say the sentences together again. The whole has been divided into 4 equal parts. One of these parts is 1/4 of the whole. That's how we write a quarter, same as before. 1 is my numerator, this time 4 is my denominator because there are 4 equal parts. Have you spotted a pattern? Can you guess what images are going to come next? Here you go, well done if you guessed that. This time there again has been another one of these equal parts added to our whole. So now the whole has been divided into 5 equal parts. One of these parts is 1/5 of the whole. 1 is still our numerator because one of these parts has been circled. 5 is our denominator because there are 5 equal parts. Now here I put all of those images above each other and I want us to think about what is the same and what is different about each of these images. So pause the video and see how many similarities and differences you can find. Okay, let's talk about some of those similarities and differences. I'm going to start off with the first thing that I noticed. I noticed in each row there is 1 red group, and in each of those red parts there are 3 children in that part. So that is the same. Is there anything else the same? Oh, every group there is the same number of children. I can see lots of groups of 3 children. That's the same all the way through. So we can start to compare the fractions. Now another thing that's the same is the numerator of each of the fractions is always 1. That's because 1 part has been circled in each of the rows. So what's different in these images? There's a different number of parts, isn't there? In the first image, there's only 1 part, and that part has been circled. So the whole of that image has been circled. In the second row, there's another part. The number of parts is increased by 1. One of those is still circled. So now, rather than the whole, now half of the group has been circled. The next image down, we said the numerator is still 1. That's because 1 part has been circled, but there is another group that's been added. So now we've gone from being 2 parts to 3 parts, and that is why our denominator has gone from being 2 to 3. Now that pattern continues in the 4th row and the 5th row. Can you see each time one extra group of children, one extra part has been added to our image? Now, if you've done the previous lessons, this image might be familiar. This image is something we've looked at and talked about before. And these two images, on the left with the children and on the right with the squares, are showing a very similar thing. We were talking before about the fraction that is shaded each time. We might not have used the word fraction the last time we thought of this. We might have just talked about the part in relation to the whole, but we said a generalized statement before. Even though, for our children, even though the number of children that is circled each time is the same, the fraction that is of the whole becomes smaller and smaller for each row because our whole is getting larger. Now that's quite a confusing sentence. Here I've tried to summarize that a bit more concisely. I'm going to read the sentence to you. Each time the part selected is a smaller part of the whole because the size of the part has stayed the same and the whole has increased in size. Let's go back to our image. We said the thing that stayed the same is the size of the part. There's 3 children in each part. Just like for our squares, there's one red square in each image that is shaded. Then the next bit says the whole has increased in size. That's also true each time for our people. An extra group has been added, and that group is the same size as the other parts, and that is the same with our squares. A tricky concept, but hopefully we can see those two patterns. Okay, this time I've still got children as my context, but I've got 2 different images again. Same question though, what's the same and what is different? I can see some similarities in both images, the image on the left and the image on the right. I can see, like I said, they're children. I can also see that there is one part that's been selected here and there's one part selected here. I can also see that in both of my images there is an equal number of children in each part. Would the fraction be the same for both images? I don't think it would. Here is 2 fractions. We have 1/3 and we have 1/5. One of those describes one of the images and one of them describes the other. Which one do you think matches with each picture? Now, I can see there's 3 children in this part. So does that mean 1/3 goes with this image? Do we talk about the number of children in each part, or do we talk about the number of equal parts? We use this sentence, don't we? Let's go back to that sentence and see if that helps us. The whole has been divided into equal parts. That's what we need to focus on. So let's look at our first image on the left here. How many equal parts has the whole been divided into? 1 part, 2 parts, 3 parts, 4 parts, 5 parts. There are 5 equal parts. One of these parts is 1/5 of the whole. So we think 1/5 will go with this image. Let's check. Is the image on the right then? Is that going to be 1/3? Let's say our sentences again. The whole has been divided into 3 equal parts. One of these parts is 1/3 of the whole. So that is 1/5, and this is 1/3. Well done if you said that to yourself. We're going to go through some more examples now. We've looked at groups of objects. This time I have got a shape. Let's see if my sentence works. The whole has been divided into equal parts. Are the parts equal? Yeah, equal in size, different orientations, but they're all triangles and they are all the same size. How many parts are there? Let's count these parts carefully. 1, 2, 3 and 4. There are 4 equal parts. Let's say the sentence. The whole has been divided into 4 equal parts. One of these parts is 1/4 of the whole. Our numerator is 1. One of those parts is red. Our denominator is 4 because there are 4 equal parts. Back with the children. I haven't seen these groups before though. How many equal parts are there? There's lots of children in each group, but do I need to count the number of children in each group? I need to see that they're the same, and I can see, luckily, from how they're laid out, that all the parts are equal in size. Let's think though about the fraction. Is any fraction selected at the moment? No. There you go. There's one part now has been selected. Now let's see if we can say these sentences together. The whole has been divided into 4 equal parts. One of these parts is 1/4 of the whole. That's how we write our quarter, same as before. 1 as my numerator, 4 as my denominator. Have you remember this image? Saw this in a previous lesson. Here, I've got to use my visualization. I've got to think about inside of this shape. There's some dotted lines to help me and some little lines on the side to help me think about how many of the green parts would there be in the whole. I can do some picturing. I can think about there's a green box here, another green box would go in front of it, a green box next to it, and another green box. Do you agree with me? There will be 4 equal parts in the whole. Let's say these sentences together. The whole has been divided into 4 equal parts. One of these parts is 1/4 of the whole. Same as before, that's how we write 1/4. You spotting a pattern? Keep thinking. Final image, we've got a number line. How many parts has my number line been split into? Now remember, we're not counting the lines on the number line because there's actually 5 lines. We're counting the parts. Here is the first part, that's 1 part. Here is the second part, that's 2 parts. Here is the third part, that's 3 parts. Here is the fourth part. Again, there's 4 equal parts. Have any of the parts been highlighted? Not yet. Now I can see one of those 4 parts has been highlighted. So I know that is 1/4. Let's just say our sentences one more time so that makes sense. The whole has been divided into 4 equal parts. One of these parts is 1/4 of the whole. Well done for saying that sentence with me. Now the same as before, I've put all of those images together, and again, my favourite question, what's the same and what's different? Pause the video again, think about similarities and differences. This time I'm going to start with the differences. Each one is a different context, isn't it? The first image in the top left, that is children as different objects. In the bottom left, we've got volume, that's how much space is taken up inside of a shape. The top right, we've got a shape, this time a 2D shape. We've got some triangles, we're thinking about area, how much space inside a shape has been selected. And then we've got a number line, that idea of a linear journey. So 4 different contexts. Can you remember what fraction we said for each of these contexts? Was it the same or was it different? It was the same, wasn't it? For each of them, we said that 1/4 was selected. Written in words is 1/4. So what's the same then for each of these images? For all of them, the 1, the numerator, that means that 1 equal part has been selected each time. Let's see if that's right. For our people, yeah, I can see there's 1 group circled, 1 part circled. In our volume, I can see that I can see 1 of the 4 equal parts, and I have to imagine the other 3 of those 4 equal parts. In our shape, again, I can see that there is 1 red triangle. The other 3 triangles that make up our 4 equal parts, they're not shaded in. And for my number line, I've got 1 part that's in red and that's 1 out of the 1, 2, 3, 4 equal parts. So what is the same is in each image 1/4 has been shown. Okay, so some more practice for us. In this section, I've got 4 different images, and the different images are again of different contexts. I want you to think, does each image show the given fraction? Why is this, or why is this not the case? I want us to keep using this sentence that you must know quite well by now. The whole has been divided into equal parts. One of these parts is one of the whole. So pause the video, have a think about each one individually. Okay, we're going to go through them. So let's start with the triangle. It says, is 1/2 shaded? Let's use the sentences to help us. The whole has been divided into 2 equal parts? Are there 2 parts? Yeah, there's 2 parts. One's red and one's white. Are they equal though? They're not, are they? The red part is smaller in size than the white part, so we cannot say that 1/2 is shaded. So well done if you said that. Even though one of the parts is red, they're not equal parts, so we cannot use the fraction 1/2. What about the next image? We've got some cubes, haven't we? Let's look at the cubes. We've got blocks. One of them is yellow. 1, 2, 3, 4, 5 of them are blue. So does that mean 1/5? Is that what we write? Let's go back to our sentence to help us. The whole has been divided into, how many equal parts are there? Let's count those blocks. There's 1, 2, 3, 4, 5, 6. There's 6 blocks, isn't there? So there's not 5 equal parts, there's 6 equal parts. One of these parts is 1/6 of the whole, so that is not correct. Let's think about our next image. Is 1/4 shaded? Show me with your thumbs. Thumbs up or thumbs down? Let's go through it together. 1/4. The whole has been divided into, are they equal parts? No, the red part is larger than 2 of the white parts, so we cannot say 1/4 because there's not one of 4 equal parts that's been shaded in. So that's not right. Now I'm going to change my fraction. Are you ready? Is 1/3 shaded? What do you think? Thumbs up again? Thumbs down. Think carefully. Okay, let's go through it. I am going to try and convince some of you that might have said the incorrect answer. I'm going to change our shape ever so slightly. It's going to stay exactly the same size, but one of my lines is going to disappear. Look carefully. Did you see it? There used to be a line that went from the center of the circle out here, but I've taken it away. I haven't changed the amount of this shape that has been shaded red, but I've taken away a line. Does it look now like the parts are of equal size? It does, doesn't it? There's 2 white parts and there's 1 red part, and they are all equal size. So now we can go to our sentence. Let's say this together. The whole has been divided into 3 equal parts. One of these parts is 1/3 of the whole. So now that sentence is correct, or that question, I should say. There is 1/3 of that shape shaded. Let's go to the final example. It says, does each plate have 1/3 of the biscuits? That important question, we need to think about 2 things. Is there the right number of parts, and are all of those parts equal in size? Are they equal in size? No, they're not, are they? There's 2 biscuits in the first plate, there's 3 on the next plate, and there's 1 on the final plate, so they are not equal in size. Could I change my image though so that they did become equal in size? Which plate would I have to take a biscuit from? I'd have to take it from the middle plate, wouldn't I? Where would I put that biscuit? If I moved that biscuit, let's see that, I've moved the biscuit. Now can we describe them? Now can we see if the statement's true? It wasn't true before because the parts weren't equal, but now I've changed them. Now do we think, does each plate have 1/3 of the biscuits? Let's go back to our sentence. The whole has been divided into 3 equal parts. One of these parts is 1/3 third of the biscuits. That then would be true after we've moved that biscuit. Okay, so we've gone through lots of examples together, and now I want to talk about what I want you to practice at home. So, similar to before, I want you to go through each image and think carefully. Does each shape show the given fraction, and why or why not for each case? Still want you to use that sentence scaffold. Maybe it'd be good to draw each shape if you can, if you've got a bit of paper, and then underneath you can write the right sentence, or you could tick or cross, whatever you think. Think about some way to record your results. Each one, think carefully. Are the parts equal? Is there the correct number of parts? So then is the fraction able to be written, and is it correct? Go through each one, try not to be tricked. Same again, similar to other example, but slightly different. This time, does each plate have 1/4 of the biscuits? Same sentence scaffold, slightly different image. Think carefully, why is that the case? Why is that not the case? Can you write or say a reason for your choice? And then the final image, you will be talking with Miss Kingham in the next lesson about this. So think carefully about this. Is 1/4 of this shape shaded? You're going to have to be prepared to reason, to explain why you think 1/4 is shaded or why you think 1/4 of the shape is not shaded. Think carefully. Hope you enjoyed that. Practice those activities. See you again.